In this video, we are going to look at an example of a function which is not continuous. So when we're drawing the gradient graph of this function, we can see straight away by looking at the function that it's not continuous. Okay, so what we do is, basically if you can trace the function without lifting your pen off the paper, then it's a continuous function. But obviously you see here, when you get to x equals -3, there's a break in the graph. Therefore, it's not continuous at x equals -3. Therefore, the gradient will be undefined wherever you draw x equals -3 on your gradient graph. If we come to this part of the function again, at x equals 2, we'll see again it's not continuous. Therefore, the gradient will be undefined when x equals 2. And when we draw a gradient graph, then we're going to have open circles wherever x equals 2 on our graph. So we'll see at this point, right, if we put in what the gradient is and we run the animation, what the gradient graph's going to look like for this function. So you see here we got a linear part, the gradient is 1, so therefore we're going to have, now if you can't work out the gradient, then as long as you put a horizontal line above the x-axis, then that'll be sufficient. But at x equals -3, you have an open circle here, and an open circle up here at the point -3, 6 also. The function then, the gradient, is going to even off to 0, you see, until we get to this, the next part, where it's not continuous. So at this part, when x equals 2, you're going to end this section here, where x equals 2 on your gradient graph with an open circle, and where it starts again with an open circle. Okay. So you'll see as we go from left to right in this part of the function, the gradient is decreasing at a gradual rate, so it'll be represented like this.